So this next speaker up, I believe, has spoken at more GTACs than anybody else. He probably does not need an introduction, but I will do one. This is Simon Stewart from Facebook, and he is going to talk to us about how Facebook tests Facebook on Android. And so with that, I hand it off to you. Thank you.
Brilliant. Thank you very much for that introduction. Yes, I think I have spoken at more of these than anyone else. This is the one where I snatched the crown from James Whittaker. Sorry, James, if you're watching. Before I begin, I've been having a fantastic day today. The quality of the talks has been amazing. And the thing that I've really noticed has been just the awesome work the stenographers have been doing. Like, when I haven't been paying attention. And the signing down here is phenomenal. Just blown away by how well organized this is. So well done, Google. Keep up the good work. So how Facebook tests Facebook on Android. If I'd been thinking carefully when I named this presentation, what I would have done is I would have called it How Facebook Bakes Quality into Facebook on Android. Because we don't just test for the sake of testing, right? It isn't something that we sit there and go, you know what? I really fancy doing some pointless testing today. There's nothing I'd rather do. Actually, sometimes I do feel like that, but it's only when it's a really slow day. Why are we doing this testing? We're doing it to bake quality into our apps, right? We can't bolt quality onto an application at the very, very last minute. We can't bake security in at the very last minute either. We can't bake performance in at the last minute. And these are things that we need to be thinking of all the way through the life cycle of the application. So, yes, how Facebook tests Facebook on Android. So let me take you back to 2012. It was a long, long time ago in a galaxy right here. The Facebook app on Android, it worked, right? It was kind of fun. And it also had really, really, really lousy user experience. Here's a quote from Mark here going, "We were never able to get the quality we wanted. Looking back, that's probably one of the biggest, if not the biggest mistake we made." And why was the performance of the application so appalling? Well, actually, it wasn't that bad. But what we were doing is a pattern that's fairly common in the world of mobile applications, and that's to use the web views extensively. Facebook was a web company. We like to be able to release software. We do it twice a day now. We push to our Lives website twice a day. That allows us to iterate on things really quickly. It allows us to make a series of chronic and awful and terrible mistakes, realize that we've done something and fix it the next day. The problem is that you can't do that on a mobile app, right? Someone downloads the app and then they're stuck with it. If you've got a bug in that application, they may never update again, which is a horrific place to be in. So we'd like to retain some flexibility, and the way we did that is we used web views. And the web views on Android and iOS are suboptimal, I think is the way to describe them. There's a number of problems with them, not least of which is they're like no other browser out there, right? The Android one is based on the stock Google, Android browser, which is not Chrome, unless you're on Jelly Bean. And if you're on Jelly Bean, actually, the browser is Chrome and the web view is something completely different. The JavaScript engines tend to behave appallingly. They're very slow, they're tedious. And so what we were doing is we were making use of these web views to allow us to iterate more quickly, and it was just leading to a really poor experience for our users. So we had to stop, we reassessed. What we did is we decided we were going to make mobile a first-class experience. That went the wrong way. I could do the entire talk in reverse, by the way. Start on the final slide, begin with your questions, and then just make it up from there. Hands up if you'd like me to do that. There's one hand, 2 hands, brilliant. Next year, right? I'll be invited back for sure after this. So what we did is we decided we were going to take our engineers and we were going to train them up on mobile. And this graph here has the numbers removed, but there's a total of about 1,400 engineers at Facebook. Not all of them contribute to our mobile code base. But what happened is it was all going along fairly regularly, and then we went, what we need to do, we need to put mobile first. We took our PHP developers, we ran them through training courses, we educated them. We hired people in who were skilled at Android and mobile development, and that's the result. We had this massive uptick in the number of engineers committing code to our mobile code bases. That's a fantastic thing. We're now moving a lot faster. The important thing, though, is that it's engineers contributing to our mobile code base. There are no Android team. What I mean to say is there is no longer an Android team. We tried to do that. We tried to have a group of people who were responsible. We called them the core Android team. And they were going to be awesome, and they were going to somehow keep up with the flood of new features coming into the web. And that didn't work. So what we did is we took a step back, we reassessed again, and now what happens is each of the teams producing a feature own that feature on every platform it's on. So if you own pictures, you own it on the web, the mobile web, iOS, Android. So that's far easier for people to keep things in sync, right? There's probably people on those teams who are specialized on Android or iOS, but there isn't a group of people who are responsible for desperately trying to ape features from the web in a mobile client. And that allows us to keep parity in place, right? And that means that users get a far better experience. If something appears on the web, chances are it will also appear on the mobile client relatively soon after that. We do have spoons, so there is no Android team. Do have spoons. So what's a developer's day like? Let's say you're on one of these feature teams, right? And you're going to do something. How do we bake quality into the application? I mean, it's done all the way through the process. So let's begin with how we build. That seems to be quite an important thing to do with software. You need to build it. So we use Git at the moment for source control. It's a DVCS, and so what we do is we have a central repo, and that seemed like a good idea. Everyone works on their local machine. There are two branches that we care about day to day. Google, I know, only have one, and that's because none of their tests failed because they got the pre-submit, and it's awesome. We haven't got the pre-submit, so people check in. So there are two branches that people care about. The first one is master. That represents not a villain from Doctor Who, but the most recent version. So you can see who enjoys British sci-fi here. It's the latest version of the code. So master has everything in it that has been committed to the code base so far. It's a linear history. What we also have is a moving tag called stable that represents the last time that we were sure that our unit tests were passing. So there's master and there's stable. That's kind of fun. And all this code is checked out, for Android at least, in a single tree, with effectively 3 or 4 directories up at the top. Java, Java tests, because you never mix test and Java code. It's just not the thing that you do. Third-party libraries, we keep those out of the tree, and resources used for Android. There we go. Got my drink of water here. Yes, so it's all one tree. That's kind of fun, because we've got more than one mobile app that we make for Android. Right? There's Instagram in there, there's a Facebook app, there's a Messenger app, there's a camera app. If you download an app for Android from Facebook, it's all being built from that tree. I'll throw that all over my laptop later. Yes, people know Murphy's Law. So what does it look like when you begin working on a feature? Well, what you do is you you're probably on the stable branch. You create a new branch for your fancy feature. Hackety hack, hackety hack, hackety hack. You git commit, and you create a new feature. While you've been working, there have been N other developers also checking in code. So periodically, you want to grab their work they're doing and rebase. So you're always working on the top of the tree. You go hackety hack, hackety hack, hackety hack. When you're ready, you commit, and then you do a rebase. So what we like to do is while you're developing locally on a branch of your own, you can have as many branches as you want. You can have your commits all organized any way you want. But when we push it into master, we want a logical change to go into our code base. We don't want the individual steps you did. Now, there's a number of reasons for doing that. The first one, a logical change is a lot easier for other people to comprehend. If you want people to understand what you're doing, what you need to do is explain why you're doing it. It helps increase the quality of the code when someone comes and has a look at things. And second of all, if we need to yank your changes, it's a lot easier for us to do that if we can see the one logical change that went in rather than the intermediate steps, particularly if you're like me and you work on like 2 or 3 things at the same time. So we always just squash our commits before we run this command, arc diff. So how do we write all this code? We use IntelliJ. It's Java, right? So there's 2 choices of IDE, Vi or IntelliJ or Eclipse. Both of them are perfectly reasonable choices, but the way that we've structured our code base means that IntelliJ is actually a really good fit for us. And from a massively biased point of view, I prefer it. And Facebook is small enough that actually, an individual choice and someone advocating can really make a difference there. So, you're using IntelliJ. You want to make sure the code is good. You want to make sure the code is testable. How do you make sure the code is testable? You use dependency injection. So when you're doing object-oriented software, OO software, you've got collaborators, right? The class that you're working on collaborates with a bunch of things. And there are 2 ways that it can get hold of its collaborators. The first way was popularized by J2EE back in the late 90s, early 2000s, and was service location. You had this big thing, and you went into it in the middle of your method, and you went, thing, give me a database connection. And thing would look at you and go, here's a database connection. And that would be fine. And then sort of, 2003, 2002, early 2000s, this dependency injection phrase started becoming more popular. And that was, the major difference with that is that rather than having the method go, thing, give me one of these, the method signature, or the class under test, somehow accepted its collaborators from the thing that created it. So there's constructor-based dependency injection, where all your collaborators are passed in at construction time. And there's also setter-based dependency injection. There's also magic-based dependency injection, where you annotate things and then Guava or Spring or whatever it is that you like suddenly populates fields that you have no idea how it did it, but it's done it somehow, right? Now, the advantage with dependency injection over service location is it makes your collaborators really, really obvious, right? It encourages you to think about who your class is collaborating with. I remember I was on one project, not at Facebook, and they were using service location, and I ripped out all the singletons and I added every single thing they depended on to their constructor signature, and 14 arguments later, somebody went, that's a really big signature. It's like, yes, yes it is. Do you think we've got too many roles and responsibilities? I went, I don't know. We should probably slim that signature down somehow. It's like, yes, how are we going to do that? Thinking what we'll do is we'll split the class up and we'll have fewer responsibilities. And what they said to me is they went, we'll pass in a map. So yes, dependency injection, a really, really useful way of ensuring that your code is testable. It makes it really easy to swap out collaborators at test time, and that's vital. So you've written your code in IntelliJ. That's nice. You've used dependency injection like a good developer should. You probably want to build your code. Now, we use a tool called Buck at Facebook for building our code. Why do we use a tool that nobody else in the world yet uses? There's a number of reasons for it. What we want is, we wanted a tool that had minimal overhead when we added a new library or module to the project. Our original Ant solution had a lot of boilerplate code. It had lots of sub-modules. If you've used Maven, the way that you would do a new module is probably you'd have a top-level library and then you'd have some sort of POM that would point to it, and who knows. We want to keep boilerplate out of our code base. Boilerplate is things that machines should do for us. But we also wanted the build tool to be friendly to the IDEs. We'd structured our code in a way that actually plays really nicely with IntelliJ, and we don't want to lose that. We want really, really fast, clean builds. But we want our incremental builds to be even faster. Because as Ari said, right at the beginning of the day, doing a clean is a bug in your build system. You should never, ever need to do that. So yes, we want faster incremental builds. And what we need to do is we, ahead of time, don't know all the things that people are going to try and build. So we want to support adding ad hoc build steps. So Buck, our build system. It has 3 really important concepts in the middle of it. The first is a build rule. Now that's a procedure for, you can all read, can't you? Yeah, okay. It's a procedure for producing output files from input files. So you list a series of sources and dependencies, and the build rule runs, and you get the output. You get one output. That's the invariant of the system. You can have at most one output from a build rule. A build file contains a series of these rules. And typically it's called Buck in all capitals, which is great unless you're on a case-insensitive file system. So we declare all the rules in that. And if we want to have a dependency between 2 rules, we use a label to get to the build rule, and we call that a build target. Okay? So that's a string identifier for a build rule. This is what a target looks like. I like to read the / as from the root of the repository, so from the top level, there is a directory called javacom Facebook share. Excellent. : in which there is a Buck file, UI, with a build rule called UI. So this gives us a completely declarative path to the thing that we're attempting to build, which is nice. By the way, if you've ever used the Selenium build system, it uses exactly the same syntax as that. It's called Crazy Fun. If you work for Twitter, Pants uses, I think, exactly the same syntax. Is that right? Yes, it is. Brilliant. Good. I think it's because there is a sort of diaspora of ex-Googlers who pine for the amazing build system that Ari talked about. So yeah, what does a build rule look like? It looks like that. This is how we build a library for Android. They're called UI, so the one that we had before. We do a recursive glob over the directory structure underneath where this rule is declared. So it's not over the entire tree, it's just over the subtree beneath this. We have a series of dependencies, which are declared there, and visibility. So by default, no one else can see a build rule outside of the build file you're declared in. So you can have dependencies within a build file, but if you step outside, you need to make it visible. You can either make it public, anyone can use this thing, or you can limit the visibility to certain subsets of rules. In order to make it nice and easy to have a library that you can depend on in the rest of your code without needing to be aware of how that library is structured, with the Java library, you can also export your dependencies. So you can say, look, if you depend on me, then transitively you get all my dependencies as well, which is a nice way of composing everything. Who knows Python? What language does that look like? It's a leading question. It's Ruby. No, hang on, it's Python. Our build file is Python. We interpret the build file using the Python interpreter. We're moving to Jython because, it would be nice not to have to rely on Python being installed on the local system. But yes, so it's Python. And that allows us to do some really, really nice things. Like, if we're missing the ability to build a certain type of target, if a build rule should exist to build, iOS library, for example, we could add it to the system using a glob of rather unpleasant Python, and then just use an iOS library in the rest of our build rules. And then when we modify Buck, we can fix it, and we can bake that into the platform, and it's kind of nice. So we've got this ability to modify the build system on the fly in a Turing-complete language and a completely declarative build system. I'm not sure how I feel about that, but it is awfully convenient. So what we do, you run your builds. We build a directed acyclic graph. I was really pleased when I started working on Buck because it allowed me to use some of the computer science that I struggled through all the way through university, and use terms like directed acyclic graph with a straight face. And what we do is we analyze that graph and we build sub-parts of the tree in parallel. So we try and build everything as massively parallel as we can. Right? And that enables our builds to be significantly faster. And then because we know that if the inputs to one of the previous steps haven't changed, the output won't have changed, we can skip building that step. We can just use the cached output. And that allows our incremental builds to be nice and fast. How does IntelliJ feel about us monkeying around on a file system like this? Apparently it likes it. We run a command called buck project. And what that will do is it will scan through the entire file system for buck files, and it will generate the IntelliJ configs. So what you do is you go, I haven't got an IntelliJ config, buck project, point IntelliJ at it, and suddenly everything works out quite nicely. That will also set up some exports for build rules, for test runners and things like that. So that's nice. And it's fast, guys. This thing is quick. Because if you want people to write tests, if you want them to be using dependency injection, if you want them to be doing all these things that we want to encourage people to do, being slow doesn't help. Again, Ari's slide, the developer who was sleeping going, longer is better. Longer isn't better, shorter is better. Instant is best. Actually, if it could somehow leap forward in time and give you the results before you finish writing the code, that would be better still. But assuming we're constrained by the laws of physics, instant is best. So Buck, by default, spins up as many threads as it can, 1.25 times the number of cores on your machine, as reported by Java. So if you've got HyperThreading enabled on a modern laptop, that means you've got 10 parallel builders running. 4 physical cores, 8 with HyperThreading, times 1.25, 10. And we found that by doing this, we can slash our build times. Our build time, when we were running in single-threaded mode, used to take about, 20 minutes. And we ran things in parallel, and we dropped that down to 4 minutes. That's quite nice. It's an incremental system. So we only rebuild what's necessary. There are going to be some changes that we're going to make in the future. Like, at the moment, we need to scan the file system every time we do a build to figure out what's changed. If we demonized something to watch the file system, as in turned it into a daemon rather than just told it it was bad all the time, we could go faster. And the other thing as well is, like, it would be nice to be able to do a distributed build, and if someone's built the thing you need with the same signature of the inputs, you should be able to get the same outputs. You shouldn't need to do a build. So in 2012, what happened was we flipped everyone from using Ant to using Buck. I'm just going to hide that, pull that up to the front. Can we flip to the Mac, please? Excellent. So there are 2 interesting things here. I've checked out the source code for Buck, and we build Buck with Ant because we're insane. You can see the activity monitor from OS X just down here. CPU usage is the thing to look. So what I'm going to do is let's do a clean. Going to just time a clean build of Buck and then running all its tests. So it's doing the compilation. Yep, excellent. Now it's running the test cases. It's still running the test cases. And it continues to run the test cases. And we're not going to wait, because it takes about a minute and a bit to do everything that it needs to do. So now what I'll do is I'll use Buck to run every single test in the file system, and to make it a fair comparison, I'll do a Buck clean. This will, because I'm actually in the directory that Buck is installed from, we may see a bit of Ant output as it bootstraps itself. We should be fine. But look at the CPU usage over here. What it's doing now is it's parsing everything. It's testing all the tests. It doesn't do a meme, right? And bam. In the time it took for me to describe what was going on, is run every single test in the Buck system. And that took significantly less than the minute it would have taken if we were using Ant. So that's pretty cool, right? Can we go back to the slides, please? So at the time we did the switchover, it was quicker to pop up a warning on the Ant build saying, why don't you go and download it? You could download Buck, install it on the system, and do a complete build far more quickly than you could actually do than if you finished your Ant build, which is crazy. And the good news is, Buck is open source. You can go and download it. You can go and have a play with the build system that we use at Facebook. We accept pull requests. Please send pull requests. They'd be lovely. It's pretty nice. If you want to see the documentation, just head over to facebook.github.com and take a look at that URL. It's under the Apache 2 license, so if you're working in a bank, you're worried about having to suddenly make all your source code available because you use a new build tool, relax, it's okay. It is written in Java. I know it's not trendy, but it is a perfectly workmanlike language. And a small amount of Python, which makes the Pythonistas happy. And it works on OS X and Linux. Now, the reason it doesn't work on Windows is because nobody builds on Windows. Well, none of our team currently build on Windows. I'm sure at some point there'll be a need for it. So, I mean, that's a flippant comment, and it was fine. And, of course, we build Buck with Ant. So, yes, we've got this amazingly fast build time, right? And that allows us to test. Testing's good, right? We get our developers to write the tests. At Facebook, there is no SET, no SDET, no TE, no QAE, no test department, no QA department. We just have engineers. Now, some of the engineers have a passion for testing, in the same way that some engineers have a passion for databases, some of them have a passion for security, and some of them have a passion for finding pictures of kittens on the internet and posting it to their timeline. But we get our developers to write tests. Everyone who writes a line of code is expected to also be writing tests for that line of code, which is nice, right? Seems to be working out all right for us so far, and I quite like it, right? I always find that companies that have a test team, the test team tends to be looked down on and not treated with the love and respect that they ought to be, right? I remember, yeah! I love you guys, it's okay. Yeah, I remember sort of getting interviews from people going, oh, he wasn't good enough to be a coder, but he might be okay as a tester. And it's like, no, you've got it all wrong. They're not good enough to be a tester. They might be all right as a coder. And they just go, it wasn't appreciated in the way I thought it would be. Funny that, really. So what kind of tests do we ask people to write? We start with unit tests. Unit tests run using JUnit. Ken Beck works at Facebook. We're not using TestNG. Cedric doesn't work there. Kent does. For those of you who don't know, Ken Beck wrote JUnit. Cedric wrote TestNG. And we encourage people to write unit tests to run locally on the JVM because we appreciate fast. Fast is really important. Like, move fast, break tests. That isn't the Facebook mantra, but it almost is. In order to enable people to move quickly, they're using dependency injection. We can replace collaborators at test time using EasyMock. That's one of the libraries that we use. Mockito is another choice if you're looking to do things, but EasyMock is what we settled on at Facebook. But we're building an Android app. And if you include the Android jar from the Android development kit, and you run a test using it, what tends to happen is anytime you touch anything included in that jar, you get an exception with stub being the only message in that exception. And that's because what they've done is they've provided an ABI-compatible jar with no implementations, because the implementation runs on Dalvik on a device. That makes writing tests incredibly difficult. That's a bad thing, right? We don't like that. So what we do is we use a library called Roboelectric. Again, it's open source. And what that does is it provides stub implementations or fake implementations of each of the Android methods, right? So what we can do is we can compile and test and run in the IDE on your desktop for a really fast developer feedback cycle. And that's nice because there's no compilation to Dalvik, no pushing out to the machine, the device or the emulator, and you can get that nice fast cycle time. And we appreciate fast. But unit tests don't cut the mustard, right? You will occasionally want to make sure that all the unit tests function correctly, and the software, when you plug everything together, doesn't fall over. I was on a project once which had slightly over 2,500 tests. The tests ran, it was a .NET project, the tests ran in about 2 seconds. It was amazing. And the app would consistently not start up. And it was because they'd forgotten to write integration tests and larger tests, right? And they were just using mock objects and going, yeah, it'll return null here and throw an exception here for exact same method. And you just, oh. No, guys, you need larger tests. Larger tests, there are a handful of frameworks that you can use. UI Automator, which came in API level 16, so basically Jelly Bean and above. I think it's there in ICS, but Jelly Bean and above it starts becoming useful. We use that quite a lot. We're writing our own test framework to allow you to write tests out of process and off device using UI Automator. We call it Bully because it pushes things around. I may have to come up with a better name before we open source it. Or maybe not, who knows. We also use Roboelectric for the older devices. There are some tests using that. We use Monkey Runner. We use a whole series of tools that come with the Android development kit, and they're all quite nice. But Roboelectric, UI Automator, those are two of the key ones that we use. By the way, we also run things like power tests and on-device tests and things like that. But these are tests that the standard normal developers write rather than crazy ones who really enjoy testing. You built the code, you tested the code. You kind of think it works, right? So you're ready. You're going to push it into master. So you remember way back in the black slide, there was arcdiff, right? What does arcdiff actually do? Kicks off the code review process, right? You'd write a description of what you do, you write a test plan, and if the test plan goes wrong, or the written equivalent, you tend to be told off and told to improve your test plan. And we send it up to a tool called Fabricator, which is like a Swiss Army chainsaw of project management. So it does tasks, it does code reviews, it does browsing of repositories. It allows you to do all sorts of clever, wonderful things. And we like Fabricator at Facebook. This is what a code review looks like. You can see here that the chap has submitted a reasonable test plan. It has been grayed out, but it's in purple. The reviewer has come back and asked him to make some changes. The developer has made some changes. That's what the little icon second from the bottom does. And then the reviewer's gone, this is good. You can check it in. Now, Fabricator has a killer feature, and I don't know if you can tell what it is. It's image macros. In the middle of your code review, you can just type a little line, and it will insert an image into the code review. This is American Obama, which is President Obama playing an electric guitar shaped like a bald eagle while wearing an American hat. I quite like that one. I stare at it endlessly. It's fascinating. And ship it. It's like, it's all done. Just ship it. Land the code. Do something interesting. To land it, we use a command line tool, Arc, short for Arcanist. It's the command line counterpart to Fabricator. And landing does two things. It runs lint, which can be run separately. And we use the Android linter with additional lint rules that we've added. So check for things like null pointer exceptions. So we use @nullable quite a lot from Guava. Optional as well. Like Guava library, fantastic. If you're not using it, just download it now and use it. It's one of the best things to come out of Google for developers for a long, long time. It's awesome. We also make sure that all the APIs for the versions of Android that we support are all present, and other bits and pieces. And then we do an arcland. What arcland does is it takes your changes in your local branch, rebases them onto master, and then pushes your version of master into the central one. So if you take a look at the history of the project in Git on master, it's a single linear history. We don't have weird branching. It's just a straight down linear history of logical changes. Right, so you've landed your code, you tested it, it's all wonderful, right? No, hang on. We also have a continuous build system. If you haven't got a continuous build system yet, just use one. I don't care what you use, cruise control, Go, we use BuildBot, right? And you can see here that most of the time, things are pretty good. One developer has caused a test to fail, and so we're not going to move the the stable branch. But when these tests all go green, then we go excellent. And these are sort of longer running tests. So these are integration tests, end-to-end tests that we don't want a developer to run on a local workstation because there just isn't time in the day. And if you're not breaking the continuous build server periodically, you're probably not working hard enough. That's what one of my friends used to say. I think he's right, actually. I think it's OK to break the build periodically as long as you fix it immediately afterwards, possibly by yanking your change out, reworking it, and resubmitting it. So BuildWhat runs all these longer-running tests, these power tests, make sure there are no regressions in performance or anything like that. And we're done, right? Oh, crap. Sorry, Nakam, you win the bet. He betted that I wouldn't profane. Does that count as profanity? I don't know. Shit. There we go. Done it properly now. So, yes, it's built. We need to dog food this thing. As I said before, when you get this application on your phone, if it falls over, a user may never download it again. That would be an awful, awful thing to happen. So we dog food extensively. And one of the platforms that we make sure that we dog food on is Gingerbread. Problem is, at Facebook, many of our developers are paid well enough to be able to afford an ICS or Jelly Bean device, right? And we can ask for like a Galaxy Nexus for testing and things like that. But Gingerbread is still incredibly popular. They're still churning out devices with Gingerbread on it. These are the latest numbers from the dashboard that Android have on their website. And you can see Gingerbread is about 45% of the market. So what we do is we make sure that people are voluntarily using Gingerbread as their primary device, and they're dog fooding our application. So they install the beta builds on their device, and they keep on using that. One of the key people using Gingerbread as their day-to-day device is a release manager for Android. He's not always the happiest person. But he often flags up pretty nasty regressions that no one else has caught yet, because they only show up as sort of outer memory exceptions on Gingerbread, where the devices are more constrained. So this is the PHP Hammer, by the way. I don't know if you've seen it. It has nothing to do with the talk. I just love the picture. So you've downloaded the beta version of the app. You've sideloaded it. What it does is it periodically, at Facebook at least, contacts the build services and goes, is there a new version of the application? And if there is, it nags people to update it. So it downloads it in the background and then goes, would you like to install it? Would you? Would you? Would you? And you go, yeah, all right. And so once you're on the testing track at Facebook and you're always using the beta build, you're always using the most recent beta build, which prevents sort of old bugs being filed by people. And filing bugs is incredibly easy, because what people do is they take their device and they shake it. Now, we call it a rage shake, because you normally only shake your device when you're going, it's not working! Oh, hello, I can file a bug. Excellent. And that's kind of a really nice feature, right? So we get good instant bug reports from people as they're experiencing it using the latest version of the application, which allows us to do our releases. Our releases? Never thought I'd get there, did you? So you can pick two when you're doing a release. You can have features, quality, or a regular schedule. Wow, that's a kind of tough choice. If there are any project managers in the audience, features, quality, schedule is not 2, that's 3. So we decided that we were going to do time-based releases, which are high quality. That means that occasionally we ship without features that we've been working on. Right? Now, the advantage of a time-based release, our releases are about 4 weeks long. So what we do is we cut a branch, we do stability work for about 3 weeks, we have a release candidate for about a week, where we push it out to the beta testers and anyone in Facebook who volunteers for it, and then we ship to the Play Store. So once a month, there's an update to the Facebook application. And it's really nice having that regularity, because it means if you're working on a feature and you miss this release, you know that you're not going to have to wait forever before the next release, right? It means that you can get this stuff as quickly as possible. And it means, you've got that consistency, that regularity. You also know that your feature isn't going to be blocked as somebody else frantically tries to finish their thing. That's nice. So time-based releases are hugely, hugely valuable to us. And done isn't just, hey, it compiles and the test pass and, Nobody's filed a bug with it yet on the release candidates. Done is things like, is the design work all finished? If we see changes going into the release branch around the design of a feature, then we know that the piece hasn't been finished. And if the feature hasn't been finished, we yank it from the release. We either hide it behind a flag and strip it out using Dex, ProGuard even, or we just remove the particular feature and we ask people to keep on working it. Logging. How do we know when we release a feature that it isn't causing a million crashes, right? We get metrics and feedback and information from the versions of Facebook that you're running on your phone. If something goes wrong, we get told about it somehow. Sometimes it depends. And we can look at that data and we can go, oh, crikey, there's been a sudden spike in crashes on this particular kind of device. Let's fix that, right? So we get information from the wild. If you haven't put logging in, we can't get that information. Sometimes there are server-side changes that need to be made. We still use web views in a few places. So if you're pushing a new feature, we need to make sure it works with the old and the new version of the app. And obviously, privacy and legal review are really, really important. Facebook cares about privacy. Like, we're a social network. If people don't trust us with their data, we're dead in the water, right? So we need to really, really be concerned with privacy, and we are. And legal review, just in case. So they're just as important as a code review, and that's what done means. So that's basically how we bake quality into the Facebook application, right? We go all the way through. We run tests consistently. We encourage people to use design patterns for testability. We have defense in depth. So there are unit tests, integration tests, the continuous integration server. We have people dog fooding all the time. We encourage people to use devices that aren't commonly used by people who have got well-paid jobs, but are used widely in the real world, particularly in the smaller markets, the emerging markets. Great. So thank you very much for your time. We've got time for some questions.
Great. Thank you.
Thank you.
Thank you, Simon. That was fantastic. I really like seeing the end-to-end. We have a couple live questions, so how about we go to the left first? Go ahead and state your name, where you're from.
Hi, my name's Christian from Google. Actually work on the Guava team.
Awesome work.
Yeah, well, that's more my other teammates, but...
The JDK5 backport.
Yeah.
Fantastic.
Working on that today.
Ship it.
But, so I wanted to thank you for some really innovative work on build systems, and putting that out to the community is a really awesome thing. So I'm glad to see it. I had a question about Buck, particularly because not all companies have access to all the source code they will ever build. So how do you handle binary dependencies of things that are, third-party libraries?
Yep. There's a rule called pre-built jar,
Yeah.
where you can just check in. So we've got third-party dependencies. We don't build Guava from source, for example.
Right.
We just check in the jars.
Okay, you check in jars.
Yeah, we check in the jars. We have pre-built binary rules, and you can depend on those. The binary rules allow you to also attach source jars and Javadoc jars. And if you do that, when you run Buck project, it will actually hook in the sources so that you can browse into the source code while you're working on the code on your project.
Very sweet. And
Yeah.
obviously you have an Eclipse plugin coming soon, right?
We accept pull requests.
All right, there you go.
Okay, looks like we have time for one more question, so we'll go over here.
I'm Dave. I'm from Family Search. So you mentioned that the code's in a single tree. Is that like all of the code at Facebook, or is it just the code for Android? And the other question that kind of goes along with it is, does that mean it's all in one Git repo, and how does that perform?
So at the moment, the Android code is in one repo, the iOS code is in another, and the website is in a third repo. I think, Google have demonstrated you can smoosh everything together, and that works pretty well for Google. I mean, we saw all the stats earlier, which were amazing, right? Just totally mind-blowing. So we could do it that way, but at the moment we have separate repos for the various things. But all the Android code lives in one tree. Cool.
Okay, actually, maybe we'll just grab one more, and then I have some announcements about dinner and things like that right after this. So go ahead, last question, please.
Hey, Noah Sussman. I'm an independent consultant, but formerly of Etsy, where I designed the CI system with pre-commit because it works so awesomely for like Google and Mozilla. And so why not? Why no pre-commit? I'm fascinated.
Just because we haven't had the need for it. The other thing as well is sort of we're a relatively small company. Like I know 1,400 engineers sounds like an awful lot, but that's 1,400 engineers spread over the web, the iOS app, the Android app, working on our internal tooling, working on stuff for our data centers, just everything, right? Facebook does more than just the news feed, right? We've got messaging infrastructure, we've got groups, we've got all sorts of fun things, right? So 1,400 engineers isn't actually that many. The team working on Buck there's about 3 consistent contributors, and then there are other people who join the team for a month or 2, and then they roll back out again. So there's just isn't a huge amount of manpower. And it turns out that if you run all the unit tests before you check in, that catches most of the problems. So there hasn't been a sort of pressing need to have a pre-submit thing. When there is a need, then I think we'll do it. But Yagni is a really good mantra, right? If you've not heard of Yagni, it comes from the Agile community. You ain't gonna need it. So don't write it, don't use it until you actually have a need for it, right? And then put it in. So yeah, that's why we don't do it.
With that, thank you, Simon. Hopefully you'll join us for dinner. And
Thank you
those are
very
the
much,
announcements.
guys.